How to solve rational functions. Application problems. Featuring Bond, James Bond. James Bond's speedboat can travel 32 miles per hour in still water. It travels 150 miles upstream against the current, then returns to the starting location. The total time of the trip is 10 hours. What is the speed of the current? This problem deals with distance, rate, and time. So naturally, we'll use the equation distance equals rate times time. We're dealing with time here, so you can divide rate from both sides and get time equals distance over rate. The distance here is 150 miles, since James Bond's speedboat can go 150 miles upstream, and then it goes 150 miles back. So time equals 150 over 32, which is how many miles per hour his speedboat can travel in still water, minus the current, since he's going upstream against it. You then take 10 minus the time, because the time of the trip there and back is 10 hours. So 10 minus t equals 150, because the distance doesn't change, over 32 plus c, since going back, he is going with the current, downstream. If we want to isolate the variable t, so we get 10 over to this side and then divide by negative 1. So you get t equals negative 150 over 32 plus c plus 10. T equals both 150 over 32 minus c and negative 150 over 32 plus c plus 10. So naturally, these two must equal each other. So if you set them equal to each other and then move everything with the variable c over to one side, you get 150 over 32 minus c plus 150 over 32 plus c equals 10. We want to get rid of the denominator so that we're only dealing with the numerator. So we multiply both the numerator and the denominator of both to get the least common denominator, which is 1024 minus c squared. We get that because if you multiply these two denominators together, 32 minus c times 32 plus c, you get 1024 minus c squared. This denominator already has a 32 minus c, so it only needs a 32 plus c to get the LCD. So you multiply both the top and the bottom by 32 plus c. You do the same with this one, except this time this denominator has 32 plus c, and you need a 32 minus c, so you multiply the top and the bottom by 32 minus c. This one, being a whole number, has a denominator of 1, so it doesn't have 32 plus c or 32 minus c. So you multiply both the top and the bottom by the LCD, 1024 minus c squared. Now that we've got all the denominators to be the same, we can deal with just the numerators. And if we simplify the numerators, we get 150 times 32, which is 4800 plus 150c, plus 4800 minus 150c, equals 10,240 minus 10c squared. 4800 plus 4800 equals 9600. And if you take 150c and negative 150c and add them together, they cancel out and you get 0. So 9600 equals 10,240 minus 10c squared. If you bring 9600 over to this side, you get negative 10c squared plus 640. Factor out a negative 10 and you get c squared minus 64, which due to the difference of perfect squares factors into c plus 8 and c minus 8. This whole equation, having started as a quadratic, is equal to 0. If you isolate the separate parts and set them equal to 0, we'll get c. Negative 10 does not equal 0, so you can't do that. C plus 8, if you set it equal to 0, you get c equals negative 8. The current cannot be negative 8 miles per hour, because that doesn't make any sense. So you go on to the next one. C minus 8 equals 0. C equals 8, so the rate of the current is 8 miles per hour. If you really want to check it and do more math than we've already done, then you can plug it into the original equation. 150 over 32 minus 8 plus 150 over 32 plus 8 should equal 10, if we're right. 150 over 24, which according to the calculator is 6.25, plus 150 over 40, which according to the calculator is 3.75, when added together do make 10, so yay, we're right!